Hello everyone, today we're going to be looking at how to use the CubeMX tool. During this tutorial, we will learn how to enable GPIO pins, match those pins from the CubeMX tool to our nuclear board, and we will write a short program to control a couple LEDs. The first thing I wanted to talk about is the CubeMX tool. What it is a graphical tool which helps you configure peripherals on your board. When you first create your project, you will be automatically directed to this CubeMX tool. It is labeled as a .ioc file in your project files. Here, you will see a graphical pin layout of your L432KC microcontroller. The first thing that you'll notice is that the naming convention on the CubeMX tool and the one on our board is different. The reason for this is because the QMX tool uses the naming convention of the processor, while the Nucleo uses its own naming convention. In order to map the QMX tool to our board, I would recommend searching for a pinout diagram online. You'll find many images of something like this. Once we figure out the pin layout, we can click on an unused pin and configure it to one of its available functions. For example, if we click pin B5, we'll notice that SPI, I2C, USART, and GPIO functions are all available. You'll notice that pin B5 is currently in a reset state, which means there's no assigned configuration to it at the moment. Let's change this into GPIO output. We will do the same with pins B4 and A11. Now that we've configured 3 GPIO outputs, let's go to project and generate code. The generating of code is the main idea of the CubeMX tool. This automatically generates the initialization C code for our project. The initialization code for the GPIOs that we just configured can be seen here. I want to mention a point here. In the previous video, I mentioned a user code block where we would write our assembly instructions. Well, the point of this is because when we generate code, everything outside these blocks are automatically overwritten. So if we need to add any peripherals or configurations, everything that we've written between these user code blocks will stay the same. To begin using peripheral devices and registers, ST uses something called Hardware Abstraction Layer, or HAL. HAL is made by ST to standardize code throughout their boards and makes controlling peripherals, such as GPIOs, easier. To begin using this, I would recommend doing a quick online search for HAL documentation. You should be able to find this PDF on ST's website. Let's go to our while loop user code block and enter some functions to toggle GPIOs one by one. For our case, let's use the toggle pin and delay function. Once we're done writing out the code, let's connect the 3 pins to the rest of our circuit, which are PA11, PB5, and PB4. And upload our program onto the board. We can see that our code is working as intended, with our lights being toggled one after the other. That concludes this video. I hope this video gives you a better idea on how to use the CubeMX tool and the HAL library to work on your future labs.